our experiment is the most dominant, most read, like you see the articles most read from the Journal of Chemical Education. So they have reported yesterday about our article. Even there is a Green Chemistry Network of Royal Society of Chemistry at University of York, UK. So they every month they publish the newsletter. So in October's newsletter, they have given our experiment as a breakthrough. And then they have shown this. We have included, we have revised our monograph and we have included that experiment in this monograph. Even that monograph is translated into Hindi also. So this we have released in a conference in Jaipur. John Warner, James Clark from University of York was there, and this man is Narendra Bhojak, who translated the book into the Hindi. So we have released this. And even the DST invited us to prepare a monograph on green chemistry experiments. So we have prepared a monograph on green chemistry experiments for UG and 3G for DST. And this monograph is available on DST site. So anybody interested in green chemistry experiment can go through this site and can download the PDF file and can do the green chemistry experiment. We have recommended UGC also to introduce these experiments. Even in your, I think this is in 6th semester or 5th semester, we have introduced in BSc Honours syllabus also these experiments, this gold nanoparticle experiment will be there. So we are organizing different workshops. This is the green chemistry, all the worldwide green chemistry scientists workshop we had organized in 2013. And then I was invited for a South Africa workshop. Even Vigyan Prasar of DST Autonomous Organization invited us to write the modules on green chemistry and real world cases. So we had already written that. And I was invited for AOC conference, Asia Oceania conference, to deliver the keynote and chair a session at Taiwan. At that time, because that was the fourth one, first one was in Tokyo, then Beijing, then so that time they requested us that the next you organize in Delhi. So we had organized that in Delhi in 2015, from 15 to 17 January. Around 12 keynote address, 300 participants, and the first session was this one, all Pollen Star, John Warner, James Clark, David Constable. You can see this there. These are the all participants. Even there was the workshop UK, India, Brazil, South Africa, joint workshop on green chemistry in South Africa. So I was invited for that also. I chaired a session and we were talk in August, South Africa, Melbourne conference. I'm so happy that now everywhere green chemistry they are adopting in the course, either IITs or NITs. This was the workshop organized by NIT Patna on green chemistry, and I was the chief guest, was the director of NIT Patna. Very recently, 27 November, I went there. I went to Raipur for that and see the media covered on the workshop on green chemistry. So much response for that. This is in Punjab, 2 colleges recently organized the workshop. This is in Kanpur recently. They have organized innovative lab practices through green chemistry. So I did the keynote address here. This is actually Professor Y K Jha, former Union Minister of the State of Science and Technology and former Vice Chancellor of JNU, honored me for my popularization activity in an international conference. With John Warner, with my group, my research students, he came daily and was with my lab. These are all my group being involved in all these activities. And this is the last slide. I just want to end my talk here. You know, whenever we take new chemical or any chemical, we look for physical properties. There is state of matter, color, melting point, boiling point, solubility, electrical conductivity, and the day when we will consider these two also, along with these, we will include these two also, toxicity and impact on the environment. That day I will stop delivering lectures because chemistry itself will be great. Thank you very much for your time.
Any questions, please? Students?
Sir, in labs we use oxalate to get the leaf extracts, and you provide a very good techniques from the help of liquid CO2. What about the efficiency?
You have seen the efficiency. I have shown you the full experiment. You know,
which one is better, sir? क्योंकि हम oxalate में बड़े भी वो लगा सकते हैं, लेकिन हम इसमें कितना maximum 500 1 liter.
This is so because if you want to use in large amount, then you have to go for another method. But if you want to extract small quantities, then this is a good method. Otherwise, you have to use supercritical carbon dioxide. There's another method. Okay, but this is just to show you that what we are doing, we are developing green chemistry experiment to change the mindset. We want to show that without solvent you can do. Why are you using organic solvents? There are so many, there are 2-3 experiments there in monograph, and my group will show you those experiments also. That initially they were using, traditional use was using organic solvent. And the same thing you can do without using any solvent. So that's what we want to change the students' mindset. Because when you will go to industry or anywhere, you will have this thinking that, see, this can be done this way also. So this is our. So that's why we are going to every places, delivering lecture, that you should come on and do like what happened to the John Warner's son. This should not be repeated. Okay?
Would anyone else like to ask anything?
I would like to request Dr. Sunita Bhagat to present the moment of exhibition. Now I would like to welcome Dr. Jaspreet Kaur to introduce Professor S K Mehta.
Isha is one of our young guns who has been discovered just yesterday. So thoda hiccups chalta rehta hai. Next we have Professor S K Mehta amongst us, and he will be delivering his talk. And before he starts, I would like to tell you a brief profile of his. He is a professor and ex-chairman Department of Chemistry and Center for Advanced Studies in Chemistry at Punjab University, Chandigarh. His field of specialization is physical chemistry, colloidal chemistry, nanochemistry and drug delivery. He has many academic distinctions and honors, some being a Research Scientist Award awarded by the University Grant Commission, Dard Fellowship 1992-99, Authors Award by Royal Society of Chemistry, United Kingdom, JSPS Fellowship, Dard Honorary Advisor. He is a nominated member of DST PAC in Physical Chemistry. He has been awarded the CRSI Bronze Award Medal in 2012. These are just a few. He has a teaching experience of more than 26 years at undergraduate and postgraduate level and a research experience of more than 33 years. He is a life member of various societies in India: Chemical Research Society of India, American Nano Society, Ultrasonic Society of India. Professor Mehta has made noteworthy contributions in the field of colloidal chemistry and nanochemistry, which includes fabrications and applications of nanoparticles, stabilization, enhancement and plug carriers, synthesis of novel metallosurfactants and complexes, protein surfactant interactions, and physiochemical aspects of liquid mixture. Because most of the students are undergraduate students and some of them are working in innovation projects and other projects also. I would like to tell you that these lectures that you are hearing are a major part of that work that you are doing. Some of the students who are working on nanochemistry can easily use the processes being told in their research work. So it's better if you participate and use the idea that you are working. You are synthesizing nanoparticles. That is in your course also. So it's better if you learn what they are telling, because these are the options that you can use in daily practical lab. Thank you, sir. Please.
Dr. Rajeev. I'm really thankful to the college and the organizing committee for kind invitation, and particularly thanks to my friend Professor R K Sharma, who said that you have to come along with Professor Mahajan to deliver lectures in this ARSD college. So I really am grateful to all of you and everyone involved in this workshop. And I brought one PPT where most of the research work which we are doing I wanted to show. But by looking at the audience, that most of the students, they are undergraduate students, and I changed my mind. So I will be taking up another topic which is hot topic nowadays. As Professor Sharma also mentioned, everybody is talking about nanotechnology. It is very easy to get the funding also if you are working in this area. And since it is a hot topic nowadays, so large number of scientists working in inorganic, organic, physical, and biotechnologists or biologists, they are now involved in research based on nanotechnology. Because this is a field which is not only belongs to chemists, but also physicists, because it's a combination, physicists, biologists, chemists, but naturally the chemists are the basis when we talk of nanotechnology. So I will just, for the students particularly, because teachers may be knowing many things about this topic, but particularly for the students, I wanted to show them basis of nanotechnology and then how this can be used for various applications. And there are very wide range of applications, as you must have heard in newspapers also, magazines also. From time to time, you hear so many things about nanotechnology. Like for cancer curement, for other diseases, nanotechnology is nowadays used. Again, Dr. Sharma mentioned that there is a risk also of these nanoparticles because they are very reactive. They can penetrate through the different parts of the body. So naturally risks are there. Toxicity, one has to check whether they are toxic or not, these nanoparticles. But anyhow, the research is quite number of people are working in this area trying to find out the advantages and disadvantages of nanotechnology and so on. Now the products, daily use products which you use, also nanotechnology have penetrated. Like this beauty products particularly, which you are using in your daily life, they contain nowadays nanoparticles because they increase their efficiency. They are much more useful now. So when the question remains, what is the toxicity? Whether these will be toxic to the body, whether they can harm the body and so on. So I will touch upon these things, which is a general thing. I am not showing any research of mine. As I mentioned, I brought that PPT, but then I decided after looking at the audience that I should go for a general talk, which I give sometime to the students. So as you can see, the nanotechnology and cosmetology, what is that? This is just directly concerning about the beauty products which you are using in a daily life. Before going to the application and other information, I will just touch upon what is nanotechnology. Everybody is talking about, although some of you may be knowing certain basis of these this nanotechnology. And nano in Greek means that drop. We have this pointer we have. If we have the pointer, please. Thank you. And these nanoparticles are of the size of the order of 10 raised to the power minus 9. So that I think everybody knows. So you can see how small they are. 10 raised to the minus 9 meter. That is the size of a nanoparticle. In this size range it exists. Now we always talk about nanotechnology. Whenever we say nanotechnology, it is nanotech. This is a shortened form of the nanotechnology and the study of the controlling of matter on an atomic or molecular scale. Now, as I mentioned earlier, nanotechnology is very diverse. It's a conventional device physics. These bases of physics, laws of physics also apply in nanotechnology to completely new approaches which are based on what we call molecular self-assembly. When we say molecular self-assembly, their chemistry plays an important role because molecules which we use, they can self-assemble and create what we call self-assembly, where we can incorporate our drug material or drug molecules or other such type of systems. Now, working at a length scale of 1 to 100, we get new properties or functions. That's why it is important. Why nanotechnology is important? Because when we go to this length scale, there is 1 to 100 nanometer, that is from 10 to the minus 9 to 10 to the minus 7, then these new properties and functions arise. So that means these new properties can be effectively used, although the compounds which we are using, they have their properties. But when we go to this scale, the properties altogether change. So we can control and we can see, we can measure, we can manipulate the matter at the atomic or molecular scale, and to exploit these properties and functions, which are new properties. So ability to integrate these properties and functions into the systems spanning from nano to macroscopic. So we are now dealing in nano, and we can correlate with macroscopic properties to get different properties. This is a length scale, as you can see. These are things which are natural, again in nanometer scale, but whereas if these are man-made, a lot of use of the nanotechnology is taking place, and these are the things which are man-made, and so many things have already existed in the world, that is in the market. Name it any, for example, head of a pin. This is also now in nano range, and going to the quantization of the drug delivery systems, as we have seen. I will elaborate this in our next slides. Now, what makes these nano materials so different? That is the main question. First is extremely small size, is of the same scale as the critical size in a physical phenomena. When you study physical phenomena, you have critical size. We always look at the critical size. So this is same scale as we have in the critical state. For example, if you have a radius of a tip of a crack in a material in the range 1 to 100 nanometer, the way this crack grows into the bulk material is different than in a nanomaterial. So that is the difference we have. Let's see, fundamental electronic, magnetic, optical, chemical, and biological processes all different at this level. For example, nano capsules and nano devices present new possibilities for drug delivery, gene therapy, and medical diagnostics. So this is the development which is taking place all over the world. People are working. The most important property is the surface area. Now, in bulk material, only a percentage of atoms will be available at or near the surface or interface, like a crystal grain boundary which you have. Whereas in nanomaterial, the small size ensure that more number of atoms are present at the interface. That is the main difference, because at the interface you have more number of atoms. So when you have more number of atoms, naturally more properties will be altogether in a different way. They will vary in a different way. So the surface properties such as energy levels, electronic state, reactivity are all different from interior state. Interior state means of the bulk, and give rise to the different material properties. So this is the main difference why this nano range is much more important as compared to the normal. Just to illustrate one example, the students generally they chew a gum, gum chewed into a ball. You put in your mouth a chew gum, and then you make a ball of it and keep on chewing that. And this is in the form of a ball. When it is wet, it is in the form of a ball. Now then think about stretching this gum. Take it out and stretch it. So when you stretch it, as long as you can make, and generally students they try this, the surface or the area visible on the outside is much greater for the stretched out gum than it is from the wad of the gum. So then when it is stretched, naturally the area is much more. Area has tremendously increased. The stretched gum is likely to dry out. You know, it was in the form of a ball in your mouth, but when you have taken it out and stretched it, what is happening? It is drying out. Quickly it will dry out and it will become brittle. You know, it will become brittle faster than the ward which was, and this is due to the contact at the surface with the air. So you can see the property has altogether changed. It is in the form of a ball which is wet. When it is taken out, stretched, the property altogether changes. So this is, we are reducing the size, we are increasing the surface area. So that is the technique which is useful. Now, so transition from microparticle to nanoparticle leads to number of changes in physical properties. Increase in surface area to volume ratio is the most important point, and particle, they move into what we call realm of quantum effects, which dominates. What these quantum effects? That energy we have, as you know, when undergraduate you are studying the quantum chemistry also, and as you can see that you have discrete energy levels. So when the particle you reduce the size, the levels also the changes. So that is where we get the quantum effects. You know, in bulk you don't have quantum chemistry. Bulk they follow the classical mechanics. But when you go to the smaller size atoms or molecules, then these quantum effects dominate. And here in the nanotechnology also, when you are reducing the size, you have these quantum effects which are coming into play. So high disparity to nanocrystalline system, and properties of nanoparticles are dominated by what we call defect structures of surface, unlike those of the molecular structure in the bulk solid. So these are the differences why nanotechnology has become very, very important. Professor Sharma was showing an experiment where these gold nanoparticles, how they show different color, and you can use the light to see the difference also. Now, nanoparticles have unexpected visual properties because they are small enough to confine their electrons and produce quantum effects. This color change is because of the quantum effects. What quantum effects? That energy levels are different, and these, because of this difference in the energy levels, they emit light in different regions, and that's why you get different colors. Here, this simple example, you have silver nanoprisms in the 100 nanometer range, as you can see this, and they are giving the red color, whereas the gold spheres in 100 nanometer, they give different color, yellow color, and same type of spheres in 50 range. So now this was 100 nanometer, this is 50 nanometer. The color is entirely different. This is now green. So this way you can see the size changes, or the particle, different particles are there, and their shape changes, and you get the different color. So this is a very, very important property, which is because of the quantum effects. Now, so this is a nanoparticle, we say a new realm of matter lying between chemistry and solid state physics. Chemistry is nothing but the study of atoms and molecules, and whereas condensed matter physics deals with the solid of an infinite array of bound atoms and molecules of the dimensions greater than 100 nanometer. And if you compare these atoms and molecules, we always discuss in terms of quantum chemistry. Condensed matter we discuss in terms of solid state physics. And where is nanoscale? Nanoscale particles are in between. They are neither in quantum chemistry, neither solid state physics, and lies in between these two. So nanoscale, we say that it is neither quantum chemistry nor laws of physics which are holding, and so naturally we have to study these to understand how they behave and what are the properties. Now, today if you go to Google, as all students are using the Google, and you put there the word this nanotechnology or nanotech, and you will see that there are 7.9 million hits. So you have information, so much information about the nanotechnology. Now, This is a first $1 trillion market. So many products are coming into the market all over the world that now nanotechnology has become very, very important. You see, that first $1 trillion market, there is no other product which is earning so much of money in the market. So nanoparticle are almost influencing every facet of our life, ranging from security to medicine, so including all other properties which we can think of. Now, how it all started? There is one very example which everybody likes to quote, that Lucretius cup dated back 400 AD. This was the cup, very famous. This is a picture of that king. And you have the color opaque green cup, which turns into translucent red when the light is shown to this. So this cup, when it is shown the light, this turns into red. So this glass contains what? This contains amounts of colloidal gold and silver. So this is, as you can see, it is known 400 AD. Long back, it was, people were using it. So this gives unusual properties that as soon as light falls on this, it changes into the color. And this is nothing because of the colloidal gold and silver. Similarly, there are many examples. This decorative glaze, which is very famous, it is known as luster, and also exists long back. It is known for centuries. And it contains metallic spherical nanoparticles dispersed in a complex way of glaze, which give rise to special optical properties. So, changing the particle size changes its color. So these are the simple examples which you can see that are very, very important, which existed in our life, but nobody, has the idea what actually these are. So first mention of nanotechnology was in a talk by physicist Richard Feynman. He was a very famous scientist, and he was giving a talk at the American Physical Chemistry meeting at the Caltech on December 29, 1959, and he gave this line. He spoke this line: "There is plenty of room at the bottom." So this line has become very famous. In every nanotechnology book you will see that this line is always there. So what that means, he wanted to say that when we go to the atomic or molecular scale, we can do many things. We can manipulate individual atoms and molecules using one set of precise tool to build and operate another smaller set, and so on down to the needed scale. So we keep on going down and the properties will keep on changing, and we can manipulate according to our need, and so on. So another important breakthrough was in the nanotechnology in 1986. This Drexler, Eric K. Drexler, he wrote this book, and that was Engines of Creation, Coming Era of Nanotechnology, which was first book in '86, which is very, very popular and fundamental. The major breakthrough came when this scanning tunneling microscope was invented, which is known as STM. By using this, we can actually see the particles. So that was the biggest breakthrough, and after that there is no looking back. There are many instruments now in the market for nanotechnology purpose, and so on. But first breakthrough was this one, which was built in 1980. In 1990, another breakthrough was IBM. IBM, they were working a lot on the nanotechnology, and they managed to position individual xenon atoms on the nickel surface like this to spell out the company logo, that is STM, using STM probes, which was invented earlier, as a demonstration that this is an extraordinary new technology. Then this is another important development that happened in 1991. It was with the creation of carbon nanotubes, and people from Japan, they observed this thing that these are the first carbon nanotubes, which now produce in a number of companies on a commercial basis, because there is a lot of use of these nanotubes. So then IBM scientists demonstrated nano printing technique also, how you can print using nanoparticles and leading to ultra tiny chips, ultra tiny lenses for optics and healthcare. And then there is another important thing, development, that is fullerenes and bulky balls in '95, and these are hollow carbon spheres in the honor of this architect Buck Minister Fuller, who designed this and having similar geometry as fullerenes. Carbon nanofibers also came into existence, and you can see these are the carbon nanofibers. So you can have using carbon nanofibers, which will be very, very strong and very, very light. So that is another development which took place for the nanotechnology development. So list of the things are many, and Richard Smalley was another scientist who was very much interested in this, and he said that the list of things you could do with nanotechnology reads like much of the Christmas wish list of our civilization. So these were the words of Richard Smalley. Now, he got Nobel Prize in as you can see, 1996 for the discovery, as I mentioned, fullerene molecules, along with the other two scientists. And then came the General Motors. They claimed that first vehicle to use these materials for exterior automotive applications and running boards on its mid-size vans. Nowadays, when you buy a car, although you may not be knowing, so many of the parts which are used are based on this nanotechnology, particularly these light boards which are used. They are basically exterior, even interior nowadays, using this nanotechnology. And this editor of journal also said that we have molecular size electronic circuits as the most important scientific development in recent years. Then another important development is nanocomputers, which are based on carbon nanotubes, and these have been demonstrated. So already you have seen that the size of laptops is decreasing day and day. This is because of the basically nanotechnology concepts. And gold nanoparticle vanish order created a bacteria. So gold nanoparticles are very, very useful from the point of view that we can vanish the odor, which is always there when people are using different materials, and if we use these, the odor can be vanished. Gold nanoparticle based drugs are already being applied for many diseases, and a lot of work is again going on. Just to show one simple example, how there is a lot of talk about cancer. Cancer is increasing all over the world. So lots of people are dying. So there are more number of people working in this area, cancer area, to find out drugs which are useful. Some drugs are already available also. They are very expensive and so on. So many scientists are working in this, trying to use this nanoparticle also, how they can be effectively used to cure the the cancer. So here is just one simple demonstration that how it can work. Now here you can see we have these cancer cells which are green, and these are the healthy cells. So in the body, when cancer cells starts growing, they increase rapidly, as we know. Then how we can stop that growth? That the one way is to kill them. And how to kill them? Because otherwise you have to use radiations or chemotherapy and so on. But this is another area where a lot of work is going on. Some positive results have come also. So we use these nanoshells, and we put that into body, and they absorb around this cancer cells only. And because cancer cells, they have amino groups around it, and so these nanoparticles will bind with these amino groups. So that means they are surrounding only cancer cells, not the healthy cells. Once they surround these cells, then you can use this infrared light, and thereby killing these cancer cells. So because these infrared light, they will be absorbed by the nanoshells, and thereby they will kill the dead. You will have dead cancer cells. So that's why you can stop the growth of the cancer cells and making the person curable. So this is just one way of describing that how this can be used effectively. Now, as you can see, there are so many innovative applications, not only in energy, medicine, drugs, nanobiotechnology, optical imaging, and so on. So, but to describe all these properties takes so many days. So it can take so many days. So I will just stick to one important area, that is cosmetics. Yeah, because it's a useful area which everybody is using in some way or the other, these cosmetic products. And you will be surprised to know that nanotechnology has penetrated in this in a bigger way. And I will show some of the examples where this has been already, there are many products which you may not be knowing that this is based on nanotechnology are available in the market. So this is we say new science of skin care, which is very popular nowadays. So we say nanotechnology in the beauty industry. As such, nanotechnology is in cosmetics, it is since 1990, but it is only the last decade that marketers caught on and started using to sell these products. Our research was going on since 1990, but now it is very, very popular. Now, nanotechnology helps in healing and repair of the skin tissue, and it also prevents graying the hair and combat the hair loss. So these are the two important areas which are where it's very much used, because there are lots of products which are being produced. How they work? Nanoparticles go deeper below the skin surface to give better results, as smaller particles are more readily absorbed into the skin and repair the damage easily and effectively. Because they are of the small size, they can easily penetrate through your skin, and naturally they can be effective. So this is the way how these can be used. Now the question is how to use them. That is another important thing, because every time you cannot put an injection on your skin to make the nanoparticle penetrate into the skin. So there are some what we call delivery systems which are used, and these delivery systems are nanoliposomes, nanoniosomes, nanoemulsions. These are the simple formulations which can be easily used along with this nanoparticles, and they can be used as delivery system. Nanotechnology for UV protection, mechanical nanotribological study of hair, these are the important areas which are there. So what these delivery system does, they preserve active ingredients such as vitamins, antioxidants, and their lightness, because they are light, they are transparent, and so on. And then we have nanotechnology based cosmetic products like moisturizers, hair care products, and these makeup and sunscreens. These are also available nowadays in market. Now, talking about these delivery systems, here comes the role of what we call emulsifier. You take a surfactant, which I think you know that if you want to make emulsion, you have a surfactant, you have oil and water. As such, oil and water, they do not mix. To mix them, we use what we call surfactant, and then using a surfactant we can stabilize, we can mix oil and water together. So that system is called emulsion. And the surfactants which we are using, they are nothing but emulsifier. So the component which can help in creating a single phase system of oil and water is called emulsifier. So we can use the emulsifiers, and for example, these are micelles. If you take surfactant, just mix in water, you get the micelles. So these are the structures of micelles, because surfactant has a head group and a tail. So they can arrange in such a way that either the head group is outside because it is soluble in water, the tail is inside, pointing towards, and this is a micelle. They can arrange in this way, that is liquid crystals. They can form liquid crystals. Then there are other microemulsion, oil, water, structure, surfactant, and we also use another surfactant, that is co-surfactant. We can form microemulsion. Then by their structure, you have the vesicles. These are the vesicles which can be there, and these are liposomes if we are using the natural surfactants. For example, phospholipids. Phospholipid is the component which is available, it's a natural surfactant is available in milk also. So these are the formulations can be created using these, and these are just the fact that one can convert one formulation to the other using concentration, using ionic strength, using temperature, and so on. Now, as I mentioned that earlier, that we have one delivery system which is called nanoliposomes. Now, liposomes are nothing but vesicular structures with an aqueous core surrounded by a hydrophobic lipid bilayer created by excretion of the phospholipids. Phospholipids are the natural surfactants. So this is the structure which is formed. So this is one surfactant. It is having a head group, and this is the tail. And the next is, this is the head group, this is tail. So this forms a bilayer, and there it forms. And these are recognized as what we call GRAS, generally recognized as safe, these phospholipids as GRAS. So these are very useful delivery systems. The first liposomal cosmetic product appeared in the market was anti-aging cream, which is called Capture, launched by Dior in 1986. So this came into existence and they were selling in the market. And also liposomes have been used in the treatment of hair loss, and this is another popular product which is there, minoxidil, and this is another regain, and so on. So there are so many products which are available in the market which use this delivery system which I described earlier. Other delivery system was nanosomes. If we are using a non-ionic surfactant, because surfactants are of different types, they are anionic, cationic, or non-ionic. If we are using non-ionic surfactants based on the based vesicles, they have similar structure that of the phospholipids, and they can be have self-assembly of non-ionic surfactants in aqueous medium. So the advantage of using these diazomes in cosmetic and skin care, they increase the stability of the entrapped drugs, because we have a hollow area where inside the structure we can trap the drugs, and we can improve the bioavailability of poorly absorbed ingredients and thereby enhance skin penetration. So this is, as you can see, a commercial Nancom is available in the market. Nanoemulsions, as I mentioned the emulsions, we have nanoemulsions also. These are dispersions of nanoscale droplets here of one liquid into the other, and these are metastable systems, and whose structure can be manipulated based on the method of preparation to give different types of products like water-like fluids or gels. So depending on how you are mixing, what concentration you are preparing. So several companies, they apply and use emulsifiers for creating stable nanoemulsions for cosmetic applications. L'Oreal has several such patents in the market, and they are having technology already in the market for using different products. Now here, as you can see, the simple nanotechnology for UV protection. Many people are using this cream for UV protection because they want to save their skin from the UV rays which are coming from the sun. And here you can see zinc oxide and titanium dioxide. These are the particles, these are nanoparticles which have been widely used for many years as UV filters in sunscreen. Now the products that is nanoparticles of zinc oxide and titanium dioxide, are transparent rather than white, so they increase aesthetic appeal, are less smelly, less greasy, and more absorbable by skin. So now onwards, if you when you use these creams, you will see on the you read the instructions on that, you will find the ingredients are nothing but the presence of either zinc oxide or titanium dioxide nanoparticle is there, because this is making these creams more useful. So there are, as I told you earlier also, this titanium dioxide nanoparticles, they're being used by Nivea. Their Nivea cream contains titanium dioxide nanoparticles. And similarly, many sunscreens and moisturizer available, they use nanoparticles, including products from Boots, Avon, Body Shop, L'Oreal, Nivea, and Unilever. You find them, these creams are using either titanium dioxide molecules or zinc oxide nanoparticles. And mechanical and nanotriobiological study of hair, again in this also, again nanoparticles are being used because they allow the, we have different types of hairs. Asian hairs are different, African hairs are different, European hairs are different. So depending on the requirement, we can prepare different types of formulations for these. Nanotechnology based cosmetic products, and as you can see, as I mentioned earlier, UV protection products, anti-aging products, nail treatments, facial moisturizers, all are available which are using either zinc oxide or titanium dioxide nanoparticles. Now, nanoparticles can be used as carrier for active ingredients and provide the skin with substances in a highly targeted way, offering intensified anti-aging properties. So if you keep on applying that, they have the anti-aging properties also. Now here you can see moisturizers are applied to the skin to improve hydration, and they protect from drying and improve appearances. Most of the moisturizers which are available in the market, they are of the type oil and water emulsions with additives to improve the stability or provide benefits such as sunscreening properties, etc. So formulating oil and water emulsions for moisturizers is important, and this requires the knowledge of size distribution of the dispersed phase, that is oil, and the charge on the surface of the droplets, that is zeta potential. So these properties, the simple properties, are very, very important. When you are formulating a product, you must know what is the size of the oil which is going on, what is the total size of the nanoparticle which is used, and other properties which are required. Another product which is widely used in the world is the lipsticks. Lipsticks are very much used in our daily life, and as you can see, final appearance is very important. When you use this, final appearance is the most important, and many pigments which are used in lipsticks are particulate, including effect pigments that add silk, for example, pearlescent attributes. These smaller particles create satin and silky effects, while larger particle size create higher luster effects such as sparkle. So, but you don't require sparkle, you require effects which are, create satin and silky effects. So there again, you use nanoparticles nowadays, and to create good effects for this lipsticks. Facial powders, another important component, because this market is very, very large. That's why the research is also has become very important. Face powders may include these talc powder, again iron oxide, as you can see, zinc oxide, titanium dioxide. So these are nanoparticles are being used in facial powder also. In addition to appearance enhancement, face powders can also provide sunscreen protection with the inclusion of strong light scattering components such as zinc oxide. So zinc oxide, as you can see, is a very, very important component which is used in these. The particle size distribution of these components affects appearance, not only the appearance, stability, and sunscreen protection. deodorants, again another product which is used in daily life. In the market, if you see, there are different deodorants which are available. In some you will see that silver oils are being used. And why silver oils? Because they provide 24-hour antibacterial protection. So silver is known to protect, and this is antibacterial as such. So again, as I mentioned in the beginning, there are concerns that nano silver could pass through the skin barrier and resulting in the unwanted side effects. But as such, whatever research or observations are there are no such reports where it has affected adversely. So already in market, the market is flooded with such products, and they are using silver oils of different particle size in these materials. Sunscreen, mainly they contain nano titanium dioxides, because this makes clothes antimicrobial and keep the sunscreen transparent and acts as micronized filter in cosmetic products. Already some nanoparticles have received FDA approval, such as zinc oxide and titanium dioxide, which can be included in sunscreen right way back 1996 approval was given. So as such, FDA has responded that these are not harmful and they are not unsafe. Nanotechnology in cosmetics, although nowadays very popular, lots of products are coming into the market, but it has been existing, as I mentioned earlier also. For example, 4,000 years ago, already this lead sulfide nanoparticles, which were in the form of lead sulfide galena nanocrystals, they existed. And if you prepare nowadays synthesized lead sulfide nanoparticles of the diameter 5 nanometers, this is the same size as we have earlier existed in the, for example, in Egypt. These existed. So these are now used. This is a recent paper by in Nano Letters, that early use of lead sulfide nanotechnology for ancient hair drying formula. So same formula nowadays we are using. The products which are available, they are using the same formula which was available 4,000 years ago. So although nanotechnology was available, but only in the recent times that we have recognized its potential and so. This is how the nanotechnology-based products, they are helpful in making your hair black from brown to black. So this is how they affect. I will just skip this because there are so many things to tell now. These are the cosmetic products. L'Oreal has already in the market nanozymes of pro retinol, and there are other products from Procter & Gamble and other companies which are available in the market. So these are the virtues which are available in the market. You can buy any of these, and they have certified nanotechnology. They are well tested, and all properties are measured, and they are shown as the research results, and then only they can come into the market and they play important role in the market. So these are some of the FDA registered, and these are the cosmetic players which are employing these particles, Ava, Nivea, Boots, and all. I will just not go into detail. And these are the companies which have their products already in the market, just to convey you that so much of use of nanotechnology is there in these products also. So again, research which was done by these companies or researchers as such, now it has been patented. That's why if a company is producing a particular product, you cannot copy them. So this is their, they have the patents for that, and they are using these patents for their use. Now this is one example I just touched upon, and then try to close down that how this anti-aging cream, they are useful for the repair of skin. As you can see, this is a skin of a 21-year-old, and this is a skin of 66 years old. So this area, you can see difference here. This is now area which is being damaged after aging, So now we want that how to make this 66 years old skin like 21 years old skin. So here comes the role of the nanotechnology. Again, this collagen synthesis I will skip out, and so as you can see, while many ingredients are known to repair the damaged and aging skin, almost all these ingredients are too large to penetrate the skin cells. That the effect is very, very little. But nanoparticles in the range of 10 to 50 nanometers in size and are easily absorbed through the cell membrane to optimize cellular health. So the dermal delivery system safely delivers the ingredients deeply and evenly through the layers of the skin and directly into the skin cells had to be developed first. So this is how this happens, and it can certainly cure the skin. So this is transdermal based creams which are used in drug delivery system that transport the medication through the skin into the bloodstream, and this was the starting point in developing a safe and effective in the skin delivery system. And the results for this was that nanodometic technology which was developed for this purpose. So these are really useful and can be used. For example, if you apply these creams, you can see this is a result after 1 week and this is a result after 3 weeks. So there is an improvement in the skin appearance of the skin using these formulations. The skin stays intact as it should be, and that's why it is very important. Last few examples that you have hair care. Again, there are many shampoos or conditioners which are made with nanocluster and nanoclusters to give a hair a healthy shine. There is another example which is not still in the market. It's just reported that you can have a toothpaste, and this toothpaste is world's first such toothpaste, and promoting the oral health by supporting natural healing using nanoparticle hydroxyperoxide, the same substance as our teeth. So, this A silver plus nano silver toothpaste is manufactured and available in Korea. So when you brush in the morning, you use this. If you use this, this toothpaste, it will automatically repair your teeth. So again, there are examples because concerns also that if we use this, maybe the silver ions which are present, which are nanoparticles, may go inside the body through your mouth and then can damage other parts of the body. So again, research is going on. Maybe in future you will have such creams available in the market. Anti-wrinkle cream, again I will not take because already time is up. And there are so many examples, I'll just skip. So what finally I will say that nanotechnology is not going away. It is here to stay because there are always concerns. If some people are against this nanotechnology, they say it will not stay for long, only for some years, some excitement is there, and then it will fade away, as there are so many areas which have already faded away. But I think nanotechnology is not going away. It's here to stay, to be a part of our everyday life. It is clear that nanotechnology has the potential to bring a lot of benefits to cosmetics as well as other consumer products. Lastly, because again there are many slides which are available, but only thing is, question is, are beauty products or health products containing nanoparticles safe? Again, I mentioned earlier, there are various concerns. So now here government has to take lead. They should have agencies which first test these formulations and then allow these into the market. So that research is very, very important. So research and technology for nanotechnological these products again is a very, very important thing. Maybe there are toxic effects, but one has to prove them. And that proof can come from doing the research. And so this I will again skip because some scientists have already commented that these are very much safe till now the known formulations are all safe. So, so the cosmetic industry also needs to stop burying its head in the sand and come clean about how it is using the nanotechnology, because they have to report all the methods, how they are using this. And also government must take lead and have the potential to tell that these are safe. So in the end, I thank you all for patient listening, and I will be happy to answer any questions if there are any by younger students.
I wanted to ask one question.
Yeah, please.
We have been talking about nanotechnology, right? Why can't we go to angstrom stage? It's 10 to the minus 10. Wouldn't it be more appropriate?
If we go down from the nano size range, what will happen? We are going towards the atoms and molecules, isn't it? So already atoms and these molecules properties we know through quantum chemistry. So out of this range, this nano range is the most important, where the properties are more useful. Yeah.
If you go to the atomic range, if it is possible, wouldn't it be more, groundbreaking that we can use the most abundant